In lesson 6, we're going to examine the hospital industry. And before we get into the problem, I want to walk you through these questions. So what you want to do is you want to click on this link right here, read the article, and try to answer these questions. Now, if you get one mark wrong, what you want to do is you want to schedule time with me so we can discuss it together. That way you can change it. You only get 2 attempts per box. So you'll read this stuff, you'll answer the questions, you'll come down here, watch this video and answer that question. Then you'll use this video to solve the problem that follows. As you're solving the problem, you want to make sure all your answers are rounded to 3 decimal places before you enter them. So you want to click this link here to open up this Desmos worksheet. Now notice the equations are different than here. And then notice that your equations right here are different than mine. So what you want to do is you want to copy this demand curve. And this is the demand curve because this negative symbol here implies there's a negative relationship between price and quantity. And you'll see that when I paste it here. We have this downward sloping line here, right? So price and quantity are negative related. Then you want to grab the supply curve and then paste it right here. And this is the supply curve because as the price goes up, more and more people want to supply goods in this market or services in the market, depending on what kind of market it is, right? I'm going to click the wrench to fix the scale. I'm going to change the maximum value of Y to, I don't know, 40. And that should allow you to see it much better, right? So this is my supply curve. And this is my demand curve. And this is the demand and supply of dental surgeries performed in Los Algodones, Mexico, the city that you read about right here. I'm going to use the demand and supply curve to calculate the equilibrium. And the equilibrium number of surgeries performed, notice when I click on equation 1, this line gets thicker. And a gray dot shows up right there. The gray dot is the intersection of supply and demand. And it looks like there's 114 surgeries performed. That's quantity supplied and requested. Surgeries requested is quantity demanded. Surgeries performed is quantity supplied. There's 114 of them performed in this market per hour. And they're being performed at a price of $9.39 thousand. $9.39 thousand. P is in thousands of dollars. So 9.39 is $9,390. We press enter to see if we got it right. Now, the above supply curve models the profit maximizing decision making, or you can think of it as, since it's a dental clinic, you can think of it as income maximizing decision making. And there are 6 identical Los Algodones dental clinics in my particular model. In yours, you might have 12, you might have 11, you might have 8. I have 6. And you can see them down here. There are 6 graphs down here. There's the Marietta Dental Clinic, the Romeo Dental Clinic, Nova Dental Clinic, the Premier Dental Clinic, Rose Dental Studio, and Rene Dental. These are actually real dental clinics in Los Algodones, Mexico. And there are 6 of them in my market. You might have 11, you might have 8, you might have 9, right? The assumption is they're identical dental clinics. You walk into a dental office, what do you see? Dental chairs, you see tools, you see water vacuums that suck saliva and water out of your mouths, you see x-ray machines, right? We're going to assume that these dental clinics are identical and that they split this market equally. So what we're going to do is we're going to divide the 114 surgeries that are supplied to this market by the number of firms. In my case, I'm going to divide by 6. You have to divide by this number. I'm going to divide by 6. I get 19 surgeries supplied by each of these identical Los Algodones dental clinics. And they're supplying them at this market price of $9,390,000. Why are the dental clinics each supplying 19 surgeries? And why are they all charging the same price, $9,390,000? In a perfectly competitive market, firms, in this case, dental clinics, have no power over price. The price is the price. If they try to sell at above this price, if one tries to sell at 10,000, they're going to supply 0 surgeries because customers going to Los Algodones are going there based on the price being lower than it is in the United States. So they're going to go to the other 5 identical Los Algodones dental clinics, and they're going to get the surgeries done there for $9,390,000. So a dental clinic can't sell at above $9,390,000. Why would they want to sell below $9,390,000? At $9,390,000, they can sell as many dental surgeries as possible, right? There's no limit to the number of dental surgeries they can sell, right? So there's no reason for them to sell below 9.39. And there's a big reason why they don't want to sell above 9.39, because nobody will choose them. They'll go to the other dental clinics that are all charging the market price. So in this regard, the dental clinics, my 6 dental clinics, they're price takers. They can't make the price. It's not a duopoly because I have 6 dental clinics, right? So it can't be a duopoly. It's not a price maker because a price maker is one that can restrict output to drive the price of the demand curve. It's not that. You know, they may or may not be a heartbreaker, and they may or may not be a life taker. They're not an oligopolist. This is a competitive market. So they're a price taker. The price is the price. And they have no ability to change the price. So the price is the price, $9,390,000. Since the market supply curve is the horizontal sum of the marginal cost graphs of the 6 identical dental clinics, and these dental clinics equally split the market, this right here is the supply curve of the market, and we're saying it's the horizontal sum of these upward sloping green lines. Notice that the intersection of this green line with the price is $9,390,000 in my model, right? The demand curve is perfectly elastic, perfectly flat. It intersects the marginal cost at 19. Same thing for Rumio, same thing for Novodent, same thing for Premier, Rose, and Remy. This green marginal cost curve crosses the demand that the individual dental clinic is faced with at 19, at a quantity of 19. And in my model, 19 plus 19 plus 19 plus 19 plus 19 plus 19, that adds up to 114. So if I sum these green curves horizontally, I get the supply curve, right? So you can think of this as the market marginal cost curve. And this is the market demand curve. So this is the demand curve that they're faced with, perfectly flat. No ability to affect the price. They just take it as given. Since they split the market equally, big Q, which is the market quantity, right? This is the market quantity. In my model, it's 114. They split the market equally. Each supplies 19 surgeries. So you think of this as 19. When this is 19, 19 times 6 is the market quantity, 114 surgeries. So this right here is the supply curve, right? That's the supply curve. I'm replacing the Q with what the big Q equals. Big Q equals little q times 6. In your model, if you have like, say, 10 dental clinics, you would have 10Q here. If you have 8 dental clinics, you would have 8Q here, 8 little q. Now, remember, the supply curve is the horizontal sum of marginal cost curves. So we could think of this as MC right here, right? That's MC. As soon as I put in this little Q times 6, this becomes the marginal cost curve of the individual dental clinics. MCI stands for the marginal cost equation, of the eye dental clinic. In my model, I have 1, 2, 3, 4, 5, 6. So I have 6 versions of this equation, and they're all identical because we're assuming that. It makes the analysis easier when we assume identical. All we have to do is we have to copy this 141 straight down to here. We have to multiply 0.07 times 6. You can do that over here. 0.07, whatever your number is, times 6, which is my number, right? Number of dental clinics. And I get a slope of 0.42. If I graph this equation, I get this green line in figure 2. I get this green line in figure 3, this green line in figure 4, the green line in figure 5, and the green line in figure 6 and in 7. Under perfect competition, each dental clinic's revenue equals the number of surgeries it supplies, which is little q, times the market price for surgeries, which is, in my case, $9.39 thousand. So this is the revenue of the eye dental clinic. In my model, I have 1 dental clinic, I have a 2nd dental clinic, a 3rd dental clinic, a 4th dental clinic, and a 6th dental clinic. So this equation is identical for all 6 dental clinics. And all I did is I replaced price with 9.39. The slope of the individual dental clinic's revenue equation is 9.39, the thing in blue. Since this slope is the change in revenue divided by the change in quantity supplied, this triangle means change in revenue divided by change in quantity. If you remember from algebra, that is the rise over run, that's the slope. Holding all other factors constant, it ends up being the dental clinic's marginal revenue curve. So this is just 9.39. In economics, whenever you hear the phrase marginal this or marginal that, you have to think slope of something. Marginal revenue is the slope of revenue. Marginal cost is the slope of cost. Okay, now each dental clinic's marginal revenue equation is graphed as the market price it has no control over. So this part right here is the flat line in each of these graphs, the black flat line. That's what this is. The marginal cost of the ith firm, whether I is 1, 2, 3, 4, 5, or 6, the marginal cost equation is the green line in each of these graphs. We're going to replace this with what it equals. What does it equal? It equals 1.41 plus 0.42Q. It equals that. What does this equal? Well, this equals the 9.39. We're going to type 9.39 here. This is where profits are maximized, or if you don't want to think about it as in terms of profits, because we're talking about a dentist or a doctor, we can think of it as income. People want to maximize their income. You want to maximize your income. Maybe you do. Maybe you maximize your income by working overtime. A dentist wants to maximize your income. A doctor wants to maximize your income. Why? Maybe the reason is because they got to pay off a huge student loan debt, or they have a big mortgage payment. All these people want to maximize their income. Income is just what you take in terms of revenues, fees that you charge for your services, minus your cost. And then net income is the thing that you get to keep. Net income is the fruit of your labor as a dentist, as a doctor. And everybody has an interest in making that as big as possible because you got to pay for the car payment, you got to pay for your mortgage, and you got to pay off your student loan debt. And it just so happens that net income is maximized where marginal cost rises to just equal this marginal revenue. This is the point where marginal benefits equal marginal cost. And we know this quantity is 19 in my model. So I'm going to solve this. I'm going to solve this equation for Q. And I can do that over here. It is equal to 9.39. So I'm going to solve this for Q. I got to get rid of the I subscript. Now I'm going to copy this and paste it down here. I have 1.41 on the left-hand side, and I have 9.39 on the right-hand side. And then I have this term, which is multiplied by Q. I'm going to keep this on the left, and I'm going to move this to the right. Now to move it to the right, I'm going to subtract 141 from both sides. 141 minus 141 is 0, and 0 plus 0.42Q is 0.42Q. So I'm going to subtract 141 from this side. I got to do it on that side, right? Now, Desmos, all I have to do to calculate that is just copy this and cut it. This difference is 7.98. So I'm going to write 7.98 here. Okay, so this again is 7.98. So I'm going to replace that difference with 7.98. Now I want to divide both sides by 0.42. If I do it to the left, I got to do it to the right. Otherwise, we no longer have this property of equality. Now, 0.42 divided by 0.42 is what? That equals 1. And 1 times Q is Q. So what does Q equal? Q equals 19. I just verified that each dental clinic supplies or performs 19 dental surgeries an hour. This is not a coincidence. Let me press enter to make sure I got the answers correct. If a new dental clinic enters this market, the number of dental clinics in the market increases to 7. So I had 6, now there's 7. Why does a 7th dental clinic enter the market? Well, they enter the market because maybe the dentists in the dentist offices are all driving around Lamborghinis. If you're a dentist and you're driving a Lamborghini to your office, people are going to visit the town. They're going to see that you're driving around a Lamborghini. They're going to follow you to figure out how you bought the Lamborghini. Maybe in Mexico, they assume the worst, but they follow you and they realize you're a dentist at a dentist office. So this person goes off to dental school, becomes a dentist, and they open up a clinic in Los Algodones, Mexico. So people can figure out if you're successful or not just by what you do, where you go, and what you buy. You're sending people signals about how profitable the services you're supplying are. People aren't dumb. People will see it. People will figure out, hey, I want to do that. So they'll jump in your market. And what happens is that if the price comes down, so now we got 7 dentist offices all supplying 19 surgery. So before, each of the 6 were supplying 19. Now you got somebody supplying a 7th person supplying 19 surgeries an hour. Maybe this dental clinic is some dude from America and he got tired of all the licensing and regulations and rules and whatnot. And he decides to open up a dentist office in Los Algodones, Mexico, right? So this 7th one starts supplying 19 surgeries right across the street from the other 6. So the quantity supplied increases to what? Now we have 7, each supplying 19 dental surgeries, right? What is 7 times 19? 133. So now we have a total of 103 dental surgeries being performed per hour in Los Algodones, Mexico. Now notice what happens when I enter that number. The supply curve moves to the right. If I go along this gray line from the black curve to the blue line, the difference in quantity from here to there is 19. Let's put in our new supply curve. Also notice down here that we get our new supply curve, the equation for our new supply curve, right? If this color isn't blue, you can come up here, change the color, and then make it blue. Okay, I'm going to put another line in here. I'm going to call it y equal, and my price is 9.39. I'm going to change this to black dashed, and then I'm going to thin it out. I'm going to zoom in a little bit. That's my equilibrium initially, right? 114 dental surgeries performed at that price. If I click on this point up here, what do I got? Straight across from my initial equilibrium, I got the 133. 7th dental clinic starts supplying 19 dental surgeries per hour. 19 plus the original number, 114. 19 plus 114 is 133. Now notice at this price of $9.39 thousand, the quantity demanded, the quantity required, the quantity needed is only 114. The quantity supplied is 133. So we have a surplus of services in this market. And how do you know that there's a surplus? Your traffic in your store drops off. You have fewer people sitting in your waiting room. Your waiting room is empty. That's how you know. You don't have the normal traffic that you once had. So we have a surplus here. There's too much supply for the demand. So what ends up happening is the dental clinics, they want to put the customers back in their chairs. So they start lowering their price. And they lower their price to here, right? The price is initially $939, but only 114 people are buying the 133 dental services supplied. So what happens is the price comes down. The price comes down to 8.991 thousand. And the quantity of surgery supplied at the new equilibrium is 127.3. So the supply results in a new equilibrium, 127.3 surgeries performed, and at a new market price of $8.991 thousand. At this new quantity, each dental clinic sells what? Although the overall quantity has increased, there's now more dental clinics in Los Algodones, Mexico. In my model, there's 7. So now the dental clinics are only supplying that many surgeries per hour. Now we got to round this 3 decimal places, right? So the fact that that's a 7 makes that a 6. So there are more surgeries being performed in Los Algodones, Mexico. But the prices come down and the surgeries performed per dental clinic has fallen by almost 1 surgery per hour. The number requested exceeded the number performed. There was no change in the number of surgeries performed. Fewer dental surgeries were performed. More dental surgeries were performed. The number performed exceeded the number requested. So more dental surgeries were performed after the 7th dental clinic entered this market. Each dental clinic, though, performed fewer surgeries. So there's more dental surgeries being performed in this market. But after that 7th enters the market, each dental clinic is performing fewer surgeries. Now, the revenue per dental clinic was equal to what? Okay, so each dental clinic was performing 19 surgeries an hour. They're performing them at a price of $9.39 thousand. The original revenue of the 6 original dental clinics was $178.41. After that dental clinic entered the market, what happened to revenue? Well, now revenue is what? We have the new price, which is 8.991 times each dental clinic is selling what? 18.186 surgeries. So this is the new price in thousands of dollars. And this is the average number of surgeries performed in an hour for a total of 163.50. So now revenue per clinic is down. So their revenue now is 163.510, and their economic profit is now 0. Their cost must be 163.51. So if I take the revenues, their incomes, their total sales, the total amount of fees collected, 163.51, and I subtract off their expenses, their costs, and that difference is 0, that must mean the cost of running the dental clinic in Los Algodones, Mexico is that number. Now we want to calculate profit prior to that dental clinic entering the market. Well, the revenue prior to that dental clinic entering the market was 178.410. So if the costs haven't changed, we're just doing that to make it simple. If the costs haven't changed, the economic profit was positive. In my case, it's $14.9 thousand. Before that 7th dental clinic entered the market, everything was great for these dentists. They were making an economic profit. They could afford to buy that customized Lamborghini. After that 7th dental clinic entered the market, those profits went to 0. The revenues go down per dental clinic. The prices they can charge goes down. The number of surgeries they're performing on average per hour is going down. I can totally understand why people want government to prevent this from happening. And the incumbent clinics, they get together and they form a little monopoly. They're going to restrict quantity. They're going to have even higher margins. And that's going to be an even bigger incentive for people to enter the market and then try to capture some of those extremely high profits. The only way a cartel operating as one to become a monopoly can work over the medium term or the long run is if they can ask government to create a government monopoly, a government cartel, to make that legal. You actually see this a lot in the United States. NFL football teams. If you think about each individual football team, if it wasn't for the NFL, the cartelizing power of the NFL itself, the NFL structure, you'd probably have a lot more professional football teams. The average ticket prices would be a lot lower. There'd be a lot more professional football teams. So what they do is they work together as the NFL. And the government allows these individual companies to work together and collude to limit the number of people who can compete against them. They work together with the networks. They create these exclusive broadcast rights. So they're working together. They're colluding. Then they collude on the labor side with the draft, right? They tell young people who are very athletic and talented that they can only negotiate with a team that drafts them. So they've monopolized the labor market and they've monopolized the output market. And they limit the number of teams to maximize the collective incomes of the incumbent NFL teams. So it actually happens a lot in the United States. There's this need for these groups of people to come together and try to prevent people from entering the market and destroying these nice economic profits they have. The title figure 8 indicates the Monopoly Dental Group is the last dental clinic to enter the market. So we have the original 6 firms here. 1, 2, 3, 4, 5, 6. We have the 7th, and the 7th is called Monopoly Dental Group. And they're all identical. That's an assumption to make the analysis easier. You can see the original demand curve and the new demand curve. Black is the original, blue is the new demand curve, and green is the marginal cost curve. So the prices come down, and the amount of surgeries each performs has decreased from 19 to just over 18 per hour. Suppose this Monopoly Dental Group is on the Yuma, Arizona side of the border. And as its name suggests, it is the only provider of dental services in Yuma. Its CEO does not appreciate the competition from the 6 Los Algodones dental clinics. If it buys these 6 dental clinics, it achieves a monopoly, which results in its revenue equation being determined as follows. So now, after Monopoly Dental Group buys up all the 6 independent dental offices, now the monopoly is the only player in this market. And so the monopolist can reduce the quantity supplied, which will push the price up the demand curve. So it can create an artificial scarcity. So now it has control over the demand curve. So now the price in its revenue equation, price times quantity, the price is now the right-hand side of the demand equation. The demand equation is P equal to that expression. So this allows the monopolist to set the price. And when we distribute the Q here, this becomes quadratic, and this becomes the linear term. Now, differentiating the above revenue curve with respect to Q, you need a little calculus for that, gives you the monopolist marginal revenue. So remember what I said about marginal revenue. When you think marginal revenue, think slope. The only problem is we have a revenue equation that has a linear component and a quadratic component. If we didn't have the quadratic component, this would be the marginal revenue, but we have this quadratic component. Now, fortunately, there's a rule here. When your demand is linear, your revenue will be quadratic. When you go from the demand curve to the revenue curve, all you have to do is remember this. The marginal revenue curve that results has the same intercept as demand. The slope is twice as steep because we end up multiplying this 2 by that slope right there. And so we get not 0.03, we get 0.06. 2 times 0.03 is 0.06. Now, when I press enter here, look what happens. I get this marginal revenue equation graph. This is the graph of the marginal revenue equation. This is the original demand curve that has not changed. This is still modeling the Americans coming down to Los Algodones to get dental treatments. And this is the new supply curve. Because remember, Monopoly Dental Group in Yuma, Arizona, on the border of Mexico and the United States, it purchased all the 6 dental clinics in Los Algodones. So at the moment it purchased those 6 dental clinics, at the moment it did that, there's one owner of these 7 dental clinics. The 7 dental clinics still exist, but there's 7 of them, right? This monopoly dental group has control over 7 dental clinics. Since the market supply curve is the monopolist marginal cost curve, this is the monopolist marginal cost curve with the 7 dental clinics. Let me put it over here too. This is my demand curve. I got to keep that. This is my original supply curve. That's gone because I have this new supply curve. Let me delete that, that, and that. I'm going to copy this. I'm going to call this my marginal revenue curve. Now I can't use MR. I can't use MR here because Desmos want to multiply M times R. So I'm going to use a little m. And I'm going to change that to red to match my graph. And I'm going to multiply this by 2, so that's going to be 0.06. You can see my marginal revenue equation, my demand equation, and the graph of my marginal cost curve for the monopolist. At the intersection of marginal revenue and market supply right here, you get what the monopolist wants to perform in terms of dental surgeries. And the monopolist wants to perform 97.923 dental surgeries. If these 7 dental clinics were independently operated, they would supply or perform 127.3 dental surgeries. But together, under one management, under one ownership, they limit the number of surgeries to 97.923. Lowering output to this level allows the monopolist to push the surgery price up the demand curve. I'm going to type X equal here, and I also type a Q here. Q is going to be equal to the original quantity, 127.3. And then I'm going to just call that Q. I'm going to change it to black and dashed, and I'm going to thin it out. Done. So if I click on this, notice it's a vertical dotted line. As I reduce this, what happens to the quantity of surgeries being performed? Quantity of surgeries being performed is being reduced, right? And what's happening to the price? This dot right here is the price. As the monopolist reduces the quantity of surgeries supplied, what happens to the price here? It gets pushed up the demand curve. You see that? At the competitive equilibrium, the price is low. As we reduce the quantity of surgeries supplied, the price is increased. So if I change that to 97.923, the intersection of marginal revenue and the market supply curve, or the monopolist marginal cost curve, determines the output. It determines the profit maximizing number of dental surgeries this monopoly should perform, 97.923. That allows the price to be pushed up to 9.872. Okay, individually, these dental clinics were price takers. The monopolist is known as a price maker. Now, to make this happen, Monopoly Dental Group will what? Will it keep all of its newly acquired dental clinics open and decrease its price? No. Will it sell its newly acquired clinics to the highest bidder? No, because if it does that, that one clinic or those 2 clinics that it sells will become competitors and pull the price back down to the competitive equilibrium. Will it shut down some of the clinics it purchased to reduce output? Yeah, it'll shut down some of the clinics it purchased to reduce output. It'll close a couple of offices. Maybe it'll turn one of the offices into a pizza joint or a taco stand. It'll shut down some of the clinics it purchased to reduce its price. No, it's not going to want to reduce its price. It's going to reduce output to push the price up. However, unlike the US, the dental surgery market in Los Algodones is competitive. Marginal cost is only $6.93 for $1,000 to produce the 97.923 dental surgeries per hour, but it's charging a price of $9.872 thousand. It's got a huge profit margin. So it's making this above normal economic profit. Los Algodones is competitive, and the United States government can't revoke the licensing of dentists in Mexico. I don't think the United States government is going to subsidize dentist offices in Mexico. The above normal economic profit does not allow the monopoly to sit on its laurels and reap windfalls for decades, but it does invite entrepreneurs to roll the dice and enter the market. If the monopolists bought out those 6 dental offices, what's going to prevent them from using that money they purchased to buy new equipment, a new building, and offer even better services? Meanwhile, the monopolist is stuck with the older offices and the older equipment. So that's why these monopolists need government to cartelize their industry. And that's why the American government cannot cartelize medical and dental offices across the border in Mexico. And that's why that's very competitive in Mexico. Pulls prices down, increases access. When you read the articles that I've shared with you about Los Algodones, Mexico, you're going to see that the California Dental Association or some California doctors, you might even see some Arizona doctors or Arizona dentists warn people of having their medical procedures, their eye procedures, their dentistry services that they want to purchase in Mexico. They don't like the fact that this competition increases the quantity of these services supplied, which pulls down the prices they can charge. Now, the closer you are to Los Algodones, the bigger the problem is. The further you are, probably not as big of a problem. But I got to tell you, my brother, he drove from northern Idaho near the Canadian border down through Utah to Arizona, stayed in a hotel in Yuma, Arizona for a week, and then walked across the border to have his dental implants put in place by a Mexican dental surgeon. And when he was all done, he told me that he had his dental implants done there, and I asked him what was the difference in price. If he would have stayed in northern Idaho to have it done, it would have probably been over $10,000. He had it done down in Los Algodones, Mexico for around $2,000. That is the cartelizing power of the American dental industry, the American medical industry, the American pharmaceutical industry is probably driving prices up by a factor of 5. Licensing, restrictions, medical school licensing, dental school licensing, pharmacy monopolization through patents and FDA approval process. So the moral of the story is if you want to increase access to healthcare services, to dental services, optical services, to pharmacy prescriptions, if you want to increase access, then perhaps the solution is across the border in a little teeny town called Los Algodones, Mexico.